This video is about solving quadratic equations by completing the square. So far we've learned two methods for solving quadratic equations that don't work all of the time. And I'm going to go over those two examples first. In the first example, it's a quadratic trinomial that says equals 0. And factoring is going to work to solve this equation because I specifically chose numbers that can be factored. So I'm going to separate the x squared into x and x, and I'm going to look for something that makes 12 that adds up to 7, which will be plus 4 and plus 3. And then we set each of our factors equal to 0, and then solve both factors. So x equals negative 4, x equals negative 3. But factoring doesn't work all of the time. Square roots is the second method that we learned, and that is if you have an a term and a c term, like in the second example here, you can use square roots to solve simply by getting x by itself. So we move 18 to the other side, we divide both sides by 2, and then we take the square root, remembering to put a plus or minus in front, and the square root of 9 is plus or minus 3. So there's the two answers there. But again, square roots doesn't work all the time. So we need to come up with a method that's going to work all of the time. And the next method that we're going to learn is completing the square, which will work all of the time. That doesn't mean it's recommended all of the time, but it's a good method to learn because when it works, it's a really quick and easy method. Completing the square means to fill in an appropriate c value to create a perfect square trinomial. So you are going to be choosing your own c value for these functions so that you can factor it in the most ideal way possible, which is as a perfect square trinomial. So we've got x to the second power plus 8x plus c, and I want you to be able to fill in that c value with the appropriate number to complete the square. The easiest way to do it is to think of taking half of the b value, so that's 8 here, half of the b value, and then squaring whatever you get. So if you have half of 8, which is 4, and then square it, the c value here is going to be 16. The reason 16 is the number is because now if you imagine factoring this, you're looking for a number that multiplies to make 16 and adds up to 8, which is, of course, 4 in both parentheses. And therefore, this can be rewritten as x plus 4 to the second power. So it was a perfect square trinomial. It's a little more complicated when the b value is not an even number. So if you have a negative 7 as your b value, your c value is going to be half of negative 7 to the second power. And I prefer you to leave it as a fraction, just by squaring the numerator and the denominator, which looks scary and perhaps not that helpful, but you can factor this, even though it's not over the set of integers, by knowing that the way you obtained 49 over 4 was doing negative 7 over 2 times another negative 7 over 2. And that means this factors as x minus 7 over 2 squared. Now this is what I mean when I say this method is not always recommended. It will always work, but sometimes you create a complicated equation for yourself and you don't feel like dealing with fractions. So if you can find another method that works instead in those cases, then you should use it. But in an example like the first one on this slide, where choosing that number 16 wasn't difficult and then factoring wasn't difficult, this can be a really useful tool in solving, as you'll see on the next slide. So if we wanted to solve this equation using our completing the square method, you'll notice it's an equation now. It has an equals 0 at the end, and it also has a c value filled in. It has a plus 1 there. If you look at this and realize you're not going to be able to factor it, that c value is not helpful at all. You should start by moving the c value to the other side. So it ends up saying equals negative 1 instead. Remember, we're not trying to factor yet, so we don't need it to say equals 0 now. We could just move that 1 to the other side because it's not that helpful to us. At this step, I'd like us to fill in actually the variable plus c, so that you remember anything you do on the left side of the equation, you have to do to the right side of the equation. And you're allowed to do that. It keeps it balanced. And you can put anything you want in place of c, and it'll still be a balanced equation. So we know in place of c, we want to complete the square on the left side of this equation. So we want to do half of negative 10, which is negative 5, to the second power, which is positive 25. Your c value should always be positive because you obtain it by squaring something. You know when you square something, it's always positive. So I add 25 to both sides of this equation. At this step, sometimes I lose people. Remember where you were headed with this. You are trying to factor the left side of this equation. That's why you put the 25 there. So you want to factor this as x minus 5 times another x minus 5, which we can, of course, write as x minus 5 squared. On the right side of the equation, we're simply adding negative 1 plus 25 to simplify it. At this point, it's written in a form that you can use square roots to solve, so that's why we wanted to do this. It wasn't factorable to begin with, so we put in our own c-value that made it factorable. Specifically, it was a perfect square trinomial, so you can factor it like this and use a square root now to get rid of the second power. Square root of 24 is plus or minus 2 root 6, and then you add 5 to the other side, and you've solved your quadratic equation, which originally wasn't factorable until we added that 25 that we wanted. You must have a coefficient of 1 in front of the x squared to use this method, so that's another reason why it's sort of limiting. So if you have an equation like this with 3 in front, the first thing you want to do is look and see if you can factor out a greatest common factor, which here you can. You can take out the 3, which will leave us with x squared minus 12x plus 50 equals 0. You can divide both sides by this 3 and just get rid of it because it doesn't affect the answer at all. And then you're in a boat very similar to the example that we just did. You have an expression that can't be factored. You have a c-value that doesn't work. So move it to the other side and put your own c-value in place. C is going to be half of our b value to the second power. So that's going to be x squared minus 12x plus negative 6 to the second power, which is positive 36. Just remember to add that to the other side as well. On the left side, the whole goal was that we could factor it as a perfect square. On the right side, we simplify. Negative 50 plus 36 is negative 14. And so this example is here to illustrate that, yes, sometimes it'll come out imaginary. But now we know how to deal with imaginary numbers. We're pulling out the I. We're leaving it as the square root of 14 because it can't be simplified at all. And then we add 6 to the other side. And there are the two complex number solutions. And that is all.